All right, I'm going to be working out the problem that I did for you in class because I didn't record it. And I also will show you how to solve that problem using the graphical method. So let me share my screen on this device. All right, so I have two things here. I have the problem statement that we had earlier. This is the Rupees problem is what I'm calling it. And I'm going to show you how to slowly go through the word problem guide to get you to that model. Any more complications, let's throw in some information in here that you don't need. Those will, not organizing it will lead you to trouble. So you want to be able to solve any problem that's thrown at you that's of this similar type. So therefore, I really push you to go to the word problem guide and map everything out so that you know where everything is. And so I'm going to actually walk you through how to do this on in this example. So I'm going to go to the word problem guide. So here, you guys have told me that the first thing you see is what you're trying to optimize, which is at the end of the problem here. They want to optimize profit. Maximize is the key word that they say the word maximize. So I want to know how many sets of black and white and colored TV sets the company should produce in order to get maximized profit. So I can tell you that here goes profit, and here goes an expression that represents profit. If I look at the words here, they don't really talk. They produce two types of TVs. So the very first set of numbers that they have here, or these set here, it benefits from. This is a problem that came from another country. So really, what they mean is there's profit of $5.25 per colored black and white TV and $6.75 per color TV. So how much do I get from an X number amount of black and whites and a Y number amount of colors? Well, I multiply these amounts. So you're telling me you can see that, and I hate doing this, but I'm going to go with what you have. You're telling me that you know that this is 525X plus 675Y without knowing what the X and Y is. That's what bothers me. I want to write down what the X and Y is. But let's go with where you're at. If that's what you see, then that's what you see. All right, so here now we have to define the decision variables out of order, in my opinion, but if that's what works for you, that's what works for you. So what does X represent? Well, X represents the number of black and white TVs because I multiply that number by 525 to get the profit from the TVs. So it's an amount of black and white TVs, and it's a total number. I'm doing this fast because I've done the problem once in class. But when I asked some of you what X was, and you had just written X equals black and white TVs, I got a mix of answers. I got some answers that were profits from black and white TVs or money, but it's the number of black and white TVs. You have to know that for any type of quiz or WPR question, that's the stick. But you have to know that in general, otherwise you can't answer the question. This is the first step, actually. Here, this one's easier. It's the color TVs. And I will use the American spelling, and that's a number. Thinking through this will help you think through the rest of the problem. All the information that's on this worksheet is information that we deem necessary, that the students before you deem necessary, not me. This was totally designed by the students as we went through this course. It was not this course, but it was a business linear algebra course where all they did was problems like this. All right, so let's keep going. The next section in this asks for the numbers that you see. So the numbers and the explanations of those numbers. It's critical that you look at each number one at a time. That comes from their analysis that what they see in the word problem is what their eyes focus on is a set of numbers. So let's go look at these numbers. The first number that you see here is 200. The company has resources to make 200 sets a week. So that is a total amount. I can tell that this total number must be smaller than 200 of TVs that are made. That is a total amount, and it's a constraint because I'm constrained by I can't make more than two than this many numbers. So that's my first constraint I see. And when I did this on the board in class, I missed it. Yeah, I wasn't organized. Even my notes weren't organized. So that's the first one. Then the next one I've already used, the 2700 and 3600. Oh, wait, I haven't used it. Creating a black and this is costs. So this is costs, and these are costs. So they haven't said anything about costs, and they say that it costs 2700 to make one TV. So this is a 2700. The next number I see here. Why can't I write? In the search. Let me see if I can bring it back up. Trying to run too many things on this little surface. Here we go. So this next number that I see here, this 2700 is a cost per black and white TV. That's a per unit. So it doesn't look immediately like it's a constraint because they don't say anything about that. But if I go to the next number, which is a 3600, I think that's a 3600. That's also that's the cost per color TV. That's also per unit. And the next number they say this number here is a restraint on the amount of costs. The business should not spend more than $6,480,000 rupees total costs. That's a total, and that's a constraint. So this part here, from here to here, makes my next constraint. I can see that coming together now. It does take a while to think about it. I'm doing a quick version of my thought process, so it might take you longer. We're not used to sitting down and being patient and thinking. That's what it takes. You actually have to think through this. Then the next number you see here is this benefits. We've already kind of mapped that out. That's the objective function, which we have on top. So I've used those two numbers. You can rewrite them if you want. The 525, it's per cost, per money made for black and white. It's a per unit. The 675 was also a per money made for color. And that's a per unit. So these are part of the objective functions. It's part of the place that you make that. And then if I go down here, I can start putting together my constraints. So how do I put together my constraints? Well, the first constraint, as I had, the total number of TVs has to be smaller than 200. So I get 200. That's my cap. And the total number of TVs is going to be X plus Y. Over here, this guy here is the total number of TVs, and this guy here is an expression that is the total number of TVs. So that's my first constraint. My second constraint was on costs. It's that weird, huge number because I'm working with rupees. That's 6480000. That's my second constraint. That's my cost should not go above that, but my per unit costs are given in these two numbers, 2700 and 3600. So 2700 times X is my total cost for black and white TVs. My 3600Y is my total cost for the black and white TVs, and that gives me my second constraint. And I only had two constraints because I've gone through all the numbers. At this point, I know 100% that I have everything correct. Now, in the next video, I'm going to show you how to solve it using the graphical method.